Hello everyone, this is Module 4, Solving Equations, and this is going to be a brief tutorial video to kind of refresh your mind on how to solve equations and to provide a foundation for you to build on as you practice and experience some more instruction for solving equations. Before we begin, it's important to understand what makes an equation. If you'll remember from your earlier math classes, an equation is a math sentence that has operations like adding, subtracting, multiplying, and dividing, and it has an equal sign, so it's a complete statement. And when you're solving an equation, the goal is to reach a solution, and in math, a solution is simply a value that makes your equation true. In order to reach a solution, you are going to isolate your variable or get your variable alone by using inverse operations. And again, you know from other classes that you've had in math that inverse means opposite. So for example, if I want to solve a subtraction equation, then I would use the inverse addition in order to combat that and get my variable by itself. So let's take a look at what that is going to look like. In addition, it's a common rule and understanding in math when solving an equation, you want to keep things balanced. In order for them to stay balanced, you must apply your operations to both sides of your equation. And when I say both sides, the equal sign is what divides your problem into two. So if I add 2 to the left side of my equation, then I need to add 2 to the right side also so that everything remains balanced. Our first example is going to be, what is the solution for 2x equals 5? Now notice here that the 2 and the x are written side by side with no space, and in math that indicates that we are multiplying the 2 and the x. In algebra, the most common way to write it is side by side. So in order to isolate my x and find the solution for the number that multiplied by 2 is 5, I need to use the inverse. And the inverse for multiplication is to divide both sides by 2. That undoes my multiplication. And when I do this, 2 divided by 2 gives me 1, so I have 1x. And then 5 over 2 is equivalent to 2.5 or 2.5. This is the solution for my equation. I can easily check my solution by plugging it in and substituting it for my variable. For example, 2 times my solution, 2.5, does indeed equal 5. So that is proof that my solution is accurate. Now you see our second example, example 2, and we have 2x plus 12 equals negative 20. This is a two-step equation because it will take two inverse operations in order to solve for my variable x. So the first thing I'm going to do is rewrite my problem so I have some room to work. And I'm going to put a line down the middle to show the two sides of my equation because I want to do the same thing to both sides. Now I'm going to start with this plus 12. This is what I want to undo first or use my inverse for because you want to work your way to the variable. So the inverse of plus 12 is going to be to subtract 12 on both sides. These 12s cancel because they are opposites or additive inverses. And I will bring down what's left, 2x. And on the other side, notice that I have two negatives. And so we know from our integer rules, if you have same signs, you're going to add the numbers together and you're going to keep your sign negative. Now I have one step remaining. Again, the 2 and the x are written close together, so I know that they're being multiplied. So the inverse is to divide both sides by 2. 2 divided by 2 cancels, leaving me with 1x. On the right side, I have 32 divided by 2, which gives me 16. And then from integer rules, I know that a negative divided by a positive is negative. So my solution is x is equal to negative 16. Our third example is what we call an equation that has variables on both sides because my x's are dispersed throughout my problem. And so I will have to still use two steps in order to solve. But my strategy here will be a little bit different. My strategy is I still want to isolate my x's, my variables, but before I do that, I have to get all of my variables together. So the first thing I want to do is gather my variables together so that I can isolate them. So the first thing I want to do is I want to get my single x to the side that my 3x is on. So I will still use the inverse to do that, and the inverse of subtract x is going to be plus x on both sides of my equation. When I do that, I get 4, and 3x plus another x makes 4x's, and I bring down my plus 1. So I've gathered my variables on the right side of the problem, so now I will need to move the 1 to the opposite side so that my x's will be isolated. In order to move the 1, I will use the inverse of plus 1, which is subtract 1 on both sides. So I'm left with 4x on the right and 3 on the left. My final step in solving is to isolate the x by moving the 4. And in order to do that, I will use the inverse of multiply, which is to divide. And my final solution for x, now that it's isolated, is 3/4. Our final example is example 5, and notice here that I've brought in grouping symbols to show you what to do should you experience this. Now I still have variables on both sides, so I will want to gather them, but notice that on the left side I have 2 being multiplied with my parentheses, and on the right side I have 4 being multiplied by what's on the inside of my parentheses. So I will use the distributive property first, and remember that distribute just means to pass out. So I'm going to pass out or distribute the 2 times each factor inside parentheses, so I will get 2x, and then 2 times -5 is -10. On the right side, I will distribute or pass out my 4, and that will give me 4x plus 12. Now I have a one-level problem, and I want to gather my variables together by using the inverse. And so what I'm going to do now is I'm going to subtract my 2x to move it over to the other side. When I do that, I have left over a -10, a 2x, and a positive 12. Now I'll need to move the 12 to the other side so that my x's can be alone. So I will use the inverse of subtract on both sides, and I have 2x is equal to, notice again I have same signs, so I will add and keep my sign to get -22. Finally, I'm ready to divide up my 2 and my x because they are being multiplied, so I will divide both sides by 2, and my answer is x equals -11. And remember that at any time I can substitute my solution -11 everywhere that there's an x in my problem to check to see that I have an accurate solution. Now for practice purposes, before you go to do your homework or anything else, go ahead and try these 3 problems, and then you can check your answers and work with the next slides that follow to see if you got the correct solution. Here are the solutions for the last screen for problems 1, 2, and 3. For number 1 and number 3, if you choose, you may convert these into decimals and they would still be accurate. I encourage you to watch further videos if you need more help before going on to your homework. I hope that this has been helpful for you, and please email me if you have any questions.